All right. So hi everybody. My name is Sheryl-Ann, and I'm partner SE covering the ASEAN region. And today I'll be bringing you through these, how you can actually secure your GitOps workflow with GitHub Actions and HashiCorp Vault. So, before we go into the details of how we can secure it, right? I think we first need to set some basis and understand what is a CI/CD pipeline. So a CI/CD pipeline comprises of a series of steps that are going to be executed automatically every single time we make a change to the code and then push those changes up to GitHub, right? So the goal of this CI/CD pipeline is to really make sure that at any time we make a change to the code, we have some processes in place that is going to automatically run the CI build of the package and then automatically attempt to deploy that change off to our infrastructure. So how does GitHub Actions fit into this, right? So it is a platform to actually automate developer workflows, and the CI/CD pipeline is just one of the developer workflows that are available. So essentially, they are a small bits of codes that will be automatically executed in response to something happening in or to your repository. So the things that can happen in or to your repos are known as GitHub events. So for example, you can configure code to automatically run anytime that you commit some code on your machine and then push it to GitHub. Another few examples are like maybe anytime a pull or merge request is created or closed, anytime code gets merged into your primary branch. So these are just some examples of GitHub events. So there are many events that you could look out for, right? So anytime one of these different events occur to our GitHub repo, we can choose to run a set of workflows. But there's some problems when it comes to this, or maybe some challenges when it comes to this. So we frequently know that we need to inject certain secrets into our CI/CD pipeline. And then GitHub Actions would be a great way to trigger events based on how we want to build, test, or deploy our code. So for example, in terms of the challenges, right? In a CI/CD pipeline, maybe you would need a credential for a cloud provider to trigger an application deployment, or maybe you are uploading an application binary into a storage bucket and you need some form of credential for that. So, but these are just some examples, right? But this definitely highlights the need for us to do some form of secret injection into these kind of workflows. So there is some challenge, right? Without using some sort of secret management solution. So because users will then end up hard coding these credentials into their pipeline or even their source codes, right? And it will actually be a disaster if these secrets end up in the wrong hands, especially with GitHub. If you put it like a public repo, anybody can go in and see and collect all this information, all these secrets, right? And this will be a disaster. So instead of hard coding credentials, this is where HashiCorp Vault comes into the picture to enable teams to securely store and tightly control access to tokens, passwords, certificates, encryption keys to protect all our machines and applications. And we use this concept of the secret engine to do so. So a secret engine, they are essentially components to store, generate, or encrypt data. And they are extremely flexible, right? So it's more easy to think of them in terms of their function. So we have some secret engines that simply store and read data, like your static KV store, or maybe other secret engines that connect to other services to generate dynamic credentials on demand. So now we have an official support for HashiCorp Vault GitHub Actions. The Vault GitHub Actions actually allows you to take advantage of your secrets sourced from your Vault infrastructure for things like maybe static or dynamic secrets, and then inject these secrets into your GitHub workflows. This integration also allows you to authenticate to Vault using a various number of ways, such as tokens, app role, GitHub auth method also. So once you have authenticated to Vault, then Vault will then allow you to fetch those secrets based on what you need. And just to reiterate again, right? You probably heard this multiple times, but our philosophy or our principle, right, is that we always put workflows over technology. So what you will see in the demo later, we are going to use the same workflow. Essentially, the client, in our case, GitHub, will need to authenticate to a third-party source. And then once we have authenticated, It's we will be given a token. We'll use that token with a set of policy that is defined to it, and then we can use that token to communicate with Vault and access the secret. Right. So that is the base that I want to set, and let's hit the demo now. So let me just show my screen, desktop 2. Just want to check, is my demo visible?
Yes.
Okay, thank you. All right, so this is essentially the, this is a very simple code, right? An application code that I have downloaded already. On the side of my Visual Studio, you can see I have 4 tabs of terminals running here, all to serve different purpose, right? So first, we're going to just use the GitHub one, and we're going to just deploy the application, right? So once this application is deployed, we can actually see that this application is also using a hard-coded secret. This is not what we want, right? So we can see that it's going to, we can run a command line to echo the hard-coded secret, right? So if I do this, we can see this is the hard-coded secret. So now, we are showing a default hard-coded secret. We don't want that to happen. I'm going to start up a Vault server. It's in dev mode, having the root token as default. So before we can go into configuring our Vault server, we of course first need to export our variables. Once that is done, I'm going to configure the Vault server, right? So the GitHub workflow later, it will actually read a secret defined at a path secret/data/CI. So we're going to create now a secret, a static secret, define a policy to access the secret, and then also generate a token that has attached the policy to it and access the secret. Right. So now we are creating the secret. We're going to test whether the secret is retrievable. Yes, it is. Secret from Vault, right? And then this is the policy that we're going to create. So essentially, this is the policy named CI secret reader. The policy path enables us to read at the path secret/data/CI. So once we see that the policy has been successfully uploaded as CI secret reader, we're going to create now a variable token to capture, this token with the created policy. So as you can see, we create a token here, Vault token create, and we specify the specific policy that we want to attach to this token. So to test, right, of course, everything we need to do, we need to test whether it works first. So we're going to test with this. We've indicated that our token is going to be that GitHub repo token, and we're going to do a Vault KV get of that secret path. And okay, so we can use this token to retrieve the secret, right? So we have determined that it's usable. Now our next step is to create our GitHub repo. So I'm just going to create one here, Vault Action Snapshot. So now we're going to set up our GitHub repo to host our code. In our case, so I'm going to do a commit, and after that, we're going to use the push an existing repo from the command line. So if I do a refresh of this page, we can see that our code has been uploaded into our GitHub repo. Our next step, right, is the step of authentication, because our runner is our workflow worker, right? They will need to authenticate to the Vault server, and to do that, we will need to authenticate with our GitHub token that we have already created. So what we're going to do now is we're going to copy that GitHub repo token first, and we're going to set up a secret within our repository itself. So if I go to the repo, I click the secrets tab over here. I'm going to add in a new repository secret. I'm going to name it Vault token, and then the token value is here, right? So once this is added, Yeah, once this is added, our next step is to set up our runner. So to run GitHub Actions, right, you need to set up runners. And in our case, we're going to set up a self-hosted runner. You can actually also utilize the GitHub runner, but that is like on a pay-per-use usage, or it's a SaaS offering from GitHub itself. But instead of doing that, I'm going to use a self-hosted runner. Means you're running the runner on your own platform. So I'm running now a Mac OS, right? So I'm just easily, you can just follow all the instructions that are available over here. So we are going to use this. Okay, I should do this. Okay, download the latest runners. Essentially, this part is just following the instructions right here. That nothing extraordinary needs to be done. So we're just going to extract the installer. So once that is done, I'm going to use our GitHub runner tab. So just to yes, okay. Okay, this one. So now we're going to start the configuration of the runner itself, right? So once I execute this later, shortly, we will see like something pop up, which is this, the self-hosted runner registration. So it's now authenticating, to GitHub. Once this step has passed, we're going to begin the configuration of the runner. So we're just going to use the name of the runner default group. So just going to hit enter. I'm going to name this like Vault snapshot, the runner. Put this Vault extra labels. You see that the runner has been successfully added. And then after which I'm going to use the default work folder. So once this is done, we see all these checkboxes. You can then start to run this runner. And once this is activated, this runner is currently listening out for jobs, right? So this step is done. Our next step now is to configure our workflow. So GitHub Actions, right? They express operations that they want to accomplish through all these workflows. Then these workflows, right, as mentioned at the start, can be triggered based off of different events that take place during your entire lifecycle of your code in the repository. So now we're going to create this hidden directory. So it must always follow this directory, GitHub workflows. And then I'm going to create a workflow file named image builder. And I will run through the code in a bit once I've copied them over. All right, so moving to this step. Essentially, this is a very, very simple GitHub workflow. The name of the workflow determines how it will actually appear within the action interface of GitHub itself, which you will see in a bit once I've activated the workflow. The on specify, right, on part of the code specifies, when this workflow will actually take place. So in our case, it's going to run every time we push a commit to our repository. And then at a high level, this image builder workflow, it needs to, check out the source code, import the secret, build the image with the new secret, and this is essentially it. So we have also added a job to the workflow named build. So our job is named build, and it's running on a self-hosted runner. The build job, right, you can define multiple steps of it, right? So it always follows this flow. You have the name, the job, and the steps that you want to run. And we can see we are using the default, the core GitHub checkout action. So after the source code has been checked out, we need to fetch the secrets from Vault. So our second step will be the import secrets. And we're using the HashiCorp Vault action, a version 2.4.0. And this part is where your configuration comes in, right? The with. So we are using this action with this set of configuration. So in our case, we are using, we're defining the URL of our local hosted Vault server. We indicate to skip the verify of TLS. And we have also put in the token, right? So this is the authentication engine. The secrets.vault_token is what we have defined earlier in GitHub. It will always follow this variable first, right? So it's secrets dot whatever. So in our case, it's secrets.vault token. And after which, this is the main part, right, where we are following the, where we are defining the secrets to be retrieved from. So we are retrieving the secret from secret/data/CI, and the key is app_secret. And the next step of our process of our workflow is to build the Docker image, right? So that's why it's named build Docker image, and then we're going to see a run Docker build, and we're going to build it with the new secret. So it's going to be env app_secret. So this variable, environment variable, will follow the same name that you have indicated here. There are ways also to change the variable name. I'll show you later while we have a bit of downtime when I'm uploading this workflow to the to trigger the runner, right? So now that I've ran through the workflow, we're going to do a push and try and we want to activate this GitHub runner, right? So while that is happening, so this step may take a while. So while that is happening, I'm just going to switch. So this is essentially the GitHub Actions interface. Later, when we see the runner running, this would change and it will update to show the workflow activated. So while we are waiting for that to happen, let me just share with you this page, right? So this is the marketplace where where you can find the Vault GitHub Actions. So we are running the latest version, which is 2.4.0. And this is essentially the place that you can see, right? And get examples on how to use it, see what kind of authentication methods you can utilize. So that's why we are using the default one now, which is token. You could use app role. You could even use like the GitHub token for it as well. And one thing that I want to show is in terms of your key syntax, right? So this is what I was talking about earlier. Essentially, if you name it like this, npm token, it will take this as the environment variable. So that's why we have defined it on our right here, env app_secret. So it will always follow this name that you have indicated. But if you want to set the output name, if you want to define a specific variable name, you could also do it as such. So this is the secret, the key, right? And then this part is where you can specify the specific variable name that you want. So I think this is done. Okay. So if you there are multiple ways that you can see whether your build job or your workflow is actually completed. So I switched over to my runner tab over here. We can see that it was listening out for jobs, and then it's running the job, the build job, right? This job called build, and the job build was completed with the results successfully done. So I'm going to refresh this page. Okay, so we can see this is the workflow. We can even over here, we can see what had happened. So we had set up the job, right? And then after setting up the job, we run the actions, the checkout actions. Then our next step was to import the secrets. So we get the Vault secrets, with our workflow configuration over here. Then we built the Docker image, and essentially that was it. So post the run, what other actions it needs to do, and then you complete the job. So now we're just going to test to see whether our our application, our Docker image has been configured with our new secret. And essentially this is it, right? So we see that instead of using this is a hard-coded secret, we are seeing a secret that has been retrieved from Vault. So that comes to the end of the demo. But before that, I also want to show you some resources that you can leverage. So you can, we have a learn guide, right? The HashiCorp tutorial, it is up to date. It is it brings you through the entire process of how you can get this up and running. And of course, if you want to go into details of the specific Vault actions, these are some URLs that you can also go to. So this marketplace was what I showed you earlier. And if you want a deep dive into like this specific GitHub workflow, so there is a 1-hour YouTube webinar from I believe the GitHub partner engineer as well as our Vault technical marketing. They were speaking. It was a co-host together. They were speaking more in depth of this integration. So if you want to spend more time to learn this thing more, you can go into this webinar and see more information.